Isaac Newton, 1643 to 1727, born on January 4, 1643, in Woolsthorpe, England. Formulated the laws of motion and universal gravitation, laying the foundation for classical physics. Developed calculus independently. One day in the late 1660s, Isaac Newton was relaxing in the garden of his family home in Woolsthorpe, England. While sitting under an apple tree, an apple is said to have fallen from the tree and hit Newton on the head. This event supposedly led Newton to wonder why the apple fell straight down to the ground instead of veering off in some other direction. This line of thinking prompted him to consider the possibility that the same force that caused the apple to fall also governed the motions of planets and other celestial bodies. This idea ultimately contributed to his formulation of the law of universal gravitation. Laws of motion. In the late 1660s and early 1670s, Newton developed his three laws of motion, which revolutionized our understanding of how objects move and interact with each other. Newton formulated the law of universal gravitation, which explained how every mass in the universe attracts every other mass. This insight provided a unified explanation for both terrestrial and celestial motion. In 1687, Newton published his most renowned work, Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, commonly referred to as the Principia. This monumental work outlined his laws of motion and law of universal gravitation. Albert Einstein, 1879 to 1955. Albert Einstein was born on March 14, 1879, in the city of Ulm, which is located in the Kingdom of Württemberg in the German Empire. Einstein is best known for his theory of relativity, which transformed our understanding of space, time, and gravity. He also made contributions to the photoelectric effect and explained Brownian motion. In 1905, Einstein published his special theory of relativity, which introduced revolutionary concepts about space and time. He proposed that the laws of physics are the same for all non-accelerating observers and that the speed of light is constant for all observers, regardless of their motion. Einstein formulated the famous equation E equals mc squared, which shows the equivalence of mass and energy. This equation revolutionized our understanding of energy and matter and paved the way for nuclear energy and particle physics. Albert Einstein was awarded the Nobel Prize in Physics in 1921 for his explanation of the photoelectric effect. The photoelectric effect is a phenomenon in which light shining on a material surface causes the emission of electrons from that surface. Einstein's work on this topic provided crucial evidence for the quantization of light energy and contributed to the development of quantum mechanics. Marie Curie, 1867 to 1934. Marie Curie was born on November 7, 1867, in Warsaw, which was then part of the Russian Empire and is now the capital of Poland. Marie Curie conducted groundbreaking research on radioactivity alongside her husband Pierre Curie. They discovered two new radioactive elements, polonium and radium, in 1898. This work led to a deeper understanding of the atomic structure and the concept of radioactive decay. Marie Curie became the first woman to win a Nobel Prize, receiving the Nobel Prize in Physics in 1903 along with Pierre Curie and Henri Becquerel for their work on radioactivity. In 1911, she won a second Nobel Prize, this time in chemistry, for her discoveries of radium and polonium and her investigation into their properties. Galileo Galilei, 1564 to 1642. Galileo Galilei was an Italian astronomer, physicist, and engineer. His advocacy of the heliocentric model of the solar system challenged established views and led to conflicts with religious authorities. Galileo is renowned for his use of the telescope to make astronomical observations. In 1610, he discovered the four largest moons of Jupiter, now known as the Galilean moons, Io, Europa, Ganymede, and Callisto. This observation provided evidence against the geocentric model of the universe. Through his telescope, Galileo observed that Venus exhibited phases similar to those of the Moon. This observation supported the heliocentric model proposed by Copernicus, where Venus orbits the Sun. Charles Darwin, 1809 to 1882. Charles Darwin was an English naturalist and biologist who revolutionized our understanding of life on Earth through his theory of evolution by natural selection. Darwin's theory of evolution by natural selection transformed biology. His book, On the Origin of Species, outlined this revolutionary concept, explaining how species adapt and evolve over time. At the heart of Darwin's theory is the concept of natural selection. It posits that within any given population, individuals with traits better suited to their environment are more likely to survive and reproduce. Over generations, these advantageous traits become more common, leading to the gradual change and adaptation of species. Nikola Tesla, 1856 to 1943. Nikola Tesla was a Serbian-American inventor, electrical engineer, and physicist known for his pioneering work in electricity, electromagnetism, and wireless communication. His innovative ideas and contributions played a crucial role in shaping the modern world and the development of various technologies. Tesla made key contributions to the development of alternating current, AC, electrical systems, which are used for power distribution today. He also pioneered advancements in wireless communication and electrical engineering. His understanding of radio waves laid the groundwork for radio transmission and influenced the development of modern telecommunications. Tesla's work in remote control and automation set the stage for the development of modern robotics and remote-operated devices. Leonardo da Vinci, 1452 to 1519. Leonardo da Vinci was a renowned Italian polymath of the Renaissance period. He was born on April 15, 1452, in Vinci, Italy, and he is widely celebrated for his exceptional contributions to various fields such as art, science, engineering, anatomy, and more. Leonardo is most famous for his iconic artworks, including the Mona Lisa and The Last Supper. His artistic skills and techniques were revolutionary for his time, and his meticulous observations of the natural world influenced his artwork as well as his scientific investigations. In addition to his artistic achievements, Leonardo's notebooks are filled with sketches, diagrams, and writings that showcase his groundbreaking ideas and inventions. He conceptualized flying machines, armored vehicles, and various engineering marvels that were far ahead of his time. His interest in anatomy led him to conduct dissections of human and animal bodies, resulting in detailed anatomical drawings that provided invaluable insights into the human body's structure and function. Louis Pasteur, 1822 to 1895. Louis Pasteur was a French chemist and microbiologist who made groundbreaking contributions to the fields of medicine, microbiology, and chemistry. Established the germ theory of disease, leading to breakthroughs in microbiology and immunization. Developed pasteurization to prevent spoilage and invented vaccines for diseases like rabies and anthrax. Pasteur's research challenged the prevailing, spontaneous generation theory and established the germ theory of disease. He demonstrated that microorganisms such as bacteria are responsible for causing various illnesses. This revolutionary insight paved the way for modern microbiology and transformed medical practices. He developed the process of pasteurization, which involves heating liquids like milk and wine to kill harmful microorganisms without significantly altering the taste or nutritional value. This technique greatly improved the safety of food and beverages and extended their shelf life. He developed vaccines for diseases like anthrax and rabies. His successful rabies vaccine was a significant achievement, marking a milestone in preventive medicine and inspiring further research into immunization. Niels Bohr, 1885 to 1962. Niels Bohr was a Danish physicist who made significant contributions to our understanding of atomic structure and quantum mechanics. His work laid the foundation for modern atomic and quantum physics. Bohr proposed a model of the atom in 1913 that combined classical mechanics and quantum theory. This model introduced the idea of quantized energy levels for electrons within an atom. It explained how electrons could orbit the nucleus in specific energy levels, and transitions between these levels explained the emission and absorption of light. Bohr was a pioneer in the development of quantum mechanics, which is a fundamental theory describing the behavior of particles on atomic and subatomic scales. In 1922, Bohr was awarded the Nobel Prize in Physics for his work on the structure of atoms and the radiation they emit. Alan Turing, 1912 to 1954. Alan Turing was a British mathematician, logician, and computer scientist who made groundbreaking contributions to various fields, including mathematics, cryptography, and the development of early computers. Turing conceptualized the Turing machine, a theoretical construct that demonstrated how a simple set of rules could simulate any computation. This idea formed the basis for the development of modern computers and computational theory. Turing introduced the concept of the Turing test in a 1950 paper. This test assesses a machine's ability to exhibit human-like intelligence, becoming a foundational idea in artificial intelligence research. These were the greatest scientists of all the time. Thank you for watching. Please hit the like button and don't forget to subscribe.